Hey there, in this lesson we're going to go ahead and learn about binary. This is an introduction, so let's just go ahead and get started. Have something handy to write with if possible, just so that you can have your tools available to reflect on after or to participate while we're moving along through this. Um, we're going to go ahead and try to aim to have you be able to do these items by the time you're done with this. So hopefully you can define binary, and hopefully you can also compare binary to denary. Now don't worry if you don't understand what those two things mean. We're basically going to demonstrate how zeros and ones can be used to represent information, and by the time we're done, these fancy little words should hopefully make sense to you. All right. Now, for this piece, I'm going to ask you to go ahead and jot these items down. You might have a partner that you can work out with through this activity here. I'm sorry, not work out with, you can work with through this activity. Or you may not. You may not be in a class. You might be doing this individually. Either way, go ahead and attempt it so that you can get your brain warmed up and ready to get into the deeper stuff as we move along here. All right. So we've got 3 questions. If you're not sure how or what the questions are asking, just go ahead and jot that down. Say, I don't understand what the word blank means. That's why I can't answer the question. So just don't just put like IDK or I don't know. Try to jot down what you're having trouble with when it comes to answering the question. First question: why do computers use a base 2 system? All right. Second question: what does binary or denary mean? And then third question: why do computers use base 2 rather than base 10? So please go ahead and jot that down, or if you're working on an interactive version of this, Windows should pop up soon asking you to type in your responses to those. Okay, we're going to go ahead and move along here. If you still need more time and you're working on this individually or in a class, go ahead and pause it and then just unpause it when the whole class will resume. Okay, so let's go ahead and move along here. Take a look at these drawings here. Got a bunch of little symbols and pictures. The red arrow is pointing to one of them. What do you think that represents? Give yourself some time to think about that. Again, what do you think that represents? Okay, so this is just your best guess. I'm going to give you some more information here, and let's see how your thinking changes. So I'm showing you all of this, and now I'm going to go ahead and show you what the red arrow down here is pointing to, which is it matches here. So this is just a duplicate. And now if you follow that up to the top, you probably recognize that symbol, right? So you can probably start guessing now that those little symbols and pictures that look kind of like, huh, what is that? Is actually a representation of what we call numbers, right? And so that is how somebody in another part of the world represents 8, right? What I want to point out here is that ever since you were a little kid, preschool, kindergarten, you started the journey on learning these little drawings and squiggles. So they're just drawings or squiggles. They're just pieces of art that you've been trained to associate with values and with representations of a quantity. Okay, so remember, these are just pictures. They're not like that for everybody. You have just been trained on them. All right, that's very important because it means that the world is really big and huge, and if you're aware of that, you can control these systems or these symbols or come up with your own eventually, but they just represent other items, right? Okay, so here we go. Let's take a look at our number system. How many symbols do we use in our numerical system? And when I mean our, I mean the one that you use at school, the one that you've always kind of relied on. How many symbols do we use in our numerical system? Go ahead and take a moment and think about that. Okay. You maybe have come up with this. If not, it's okay. We've got 10 symbols, right? So we've got this symbol right here, this one, 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 this one. We've got how many? 10 symbols. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 symbols there. All right. Now, a couple of pieces of info that will help you hopefully break down some of this vocabulary that you're going to be making use of. So in Latin, that's another language that was used a long time ago. we borrowed a lot of words and kind of stole from that language, from Latin language, to build up the English language, and other languages borrowed from it. All right. So in Latin, digitus is like finger or toe. All right. And decimus is tenth in Latin. All right. So we call these symbols, these 10 symbols, we call them digits. All right, which comes from digitus. So think of your hands and all your fingers. You got 10. Look at your feet, your toes. How many do you have? 10. So we have 10 digits, which comes from the idea of digitus. A lot of people think we ended up with our number system because, a long time ago, that's what we had to count and keep track of. So that's probably why we ended up with 10 symbols. I don't know. It's a theory. Decimus. I mentioned that's 10th in Latin. That's why our system is called decimal system, right? Or you've used that word, a decimal, right? Deci from decimus, so it has to do with 10th. Denary, you might hear that mentioned here, so that's why you want to take note of it. Denary has to do again with 10. Or you might hear me mention a base 10 system. Base 10 means at the very base, at the very bottom, we have 10 symbols. So it's a system, a number system that uses 10 symbols at its base. All right, which should probably give you a hint. There's other systems that don't use 10 symbols, all right, as their base. They use another quantity of symbols in their system. All right, so let's go ahead. That's our number system. So what's the value of this symbol? So when you think of the symbols, just think symbol, symbol, symbols. Draw the quantity of apples that this symbol represents. Going to take a second there. Okay, so most people probably came up with the following, something like that, right? Obviously, I'm not talking about the color and the actual leaf and the stem, but just you probably came up with something like that, or you're thinking about something like that. Well, is this correct? I would say it depends, right? And what does it depend on? So it depends on the following: where you place the symbol 4 in the base 10 system. You see, we do have 10 symbols, but it's not where it ends. That's not where things finish. We don't teach pre-K and kindergarteners the symbols and then that's it. They're able to understand everything about all numbers. What they have to then learn, or what you then had to learn, was that once you understood and could say the names of the symbols, where you put the symbols in relation to other symbols changed what those symbols meant. In other words, if we take a look at the 4 here, right? If we put it over here all the way to the right, that symbol means 4 ones. So there we have the drawing that most people came up with in the last question. However, if instead we put the 4 in some spot like right here, the third symbol over, so not here, but over here, we're actually talking about 4 hundreds. So we would have drawn that, right? Similarly, if we would have put it here, it would have been 40 little apples, or 4,000 apples. But as you can see, we have symbols mixed with some other fancy rules, and those rules have to do with place value, right? So this is the ones place, the tens, the hundreds, and the thousands. So the symbol changes in value depending on where you put it. I'll say it again. The symbol, there's 10 of them, how much they are worth, their value, changes depending on where you place it. So you could put the symbol that we call a 4 in the ones place and it's a 4. But if you move that symbol, that same 4, that same little drawing that you call a 4 over to the tens place, now you've got a 40. If you take that same little symbol, that drawing that you call a 4, and move it over 3 spaces over to the left, now you put it in the hundreds place, so you're talking about 400. And if you move it over 4 spaces to the left, that little symbol that you call a 4 is actually 4,000. So the symbols change values depending on where you place them. Now let's recap what we've got. In a decimal system, how many symbols are used to represent a numerical value? Go ahead and think about that. And in a base 10 system, how many symbols are used to represent a numerical value? I'll give you a second here to pause and think about that, and I'll continue with the answers. Okay, if you need more time, just go ahead and hit pause there. If not, I'm going to go ahead and go through the answers here. All right, so the first one, the answer is 10 symbols. In a decimal system, we've got 10 symbols. They're called digits. In a base 10 system, the answer is 10 symbols also. They're called digits. If you recall, decimal system and base 10 mean the same thing. All right, there's 10 digits, 10 symbols that are used. And using those digits or those symbols, we can represent any value that we can imagine with this system. That is your decimal system or your base 10 system, aka your denary system. They're all the same thing. Denary, decimal, and base 10 they all mean the same thing. We're going to go ahead now and jump into a new topic, which is binary. Okay, with the binary term, let's go ahead and think of some questions first. What does bi mean? What does nary mean? And then binary, what is it? So let's go ahead and jump in. Look at this switch. It's got two states. What does bi mean? So bi means two, or comes from Latin meaning twice. So there's twice. What does nary mean? Nary means or refers to a number system. So when you combine those two terms, bi and nary, which is what you have here, binary is a number system with two symbols. This is different from the previous system we just talked about. This number system has two symbols. Now, the symbols in this system are called bits. Again, the symbols in this system are called bits. In the binary system, they're called bits, not digits. Why do you think that would be the case? All right. If you need more time, just pause it. Since the symbols used are on or off, just like the switch picture shows, or sometimes we use this, what we call an on or 1, 0 for off. We use two symbols. We can't call them digits because the digits refers to base 10. In binary, we call them bits. So we drop the DIG part and instead replace it with the BI part. So using those symbols, we can represent, just like we could with the denary, any value with the system. All right, so this system, the only difference between binary and denary is that this system only uses two symbols, but we could still represent any value that we want. All right, so here we go. In a binary system, what is the value of this symbol? Go ahead and pause it. Take a guess. It depends. So if you answered it depends, you're correct. Why? Because it depends on where you place the symbol in the base 2 position system here, just like the previous question you had. So if we place the symbol here, it represents the 1, the ones place. If you place the symbol here, it represents the value 2. If you place it here, the value 4. Over here, the value 8. So right here we don't have it. And then over here, the 16. All right, so depending on where you place the value will determine, depending on where you place the symbol will determine what value it takes. All right, so let's go ahead and recap that info. In a binary system, how many symbols are used to represent a numerical value? The answer is 2 symbols. In a base 2 system, how many symbols are used to represent a numerical value? The answer is still 2 symbols, because binary means the same thing as a base 2 system. So binary system equals base 2 system. If you have access to this link, you can go ahead and take a look at this clip. It's a binary video. You'll have that available to watch separately and in addition to what we are covering here. Okay, let's go ahead and start wrapping up and review everything that we've covered so far. You might have some questions to answer here. You can answer as you follow along, or if you're doing this interactively, you should get some questions to respond to. Why do computers use binary? because they use switches. They are stuck, they're limited to these two states. So if you're a switch, you're going to be stuck. You can only, when I mean stuck, means that you're limited. You don't have a lot of choices. All right. I don't mean like the switch is stuck and it cannot move. So switches can only pick on or off. They can only be either on or off. There's no middle. This is not one of those dimmers that has middle states. It's just either an on or an off. And so computers, because they're made up of switches, have to communicate and represent values or data using those two symbols, on or off. On, we use a 1 usually. Off, we use what we call a 0. Okay? What do you call the number system we use in our math classes at school? There's 3 possible names: denary, decimal, or base 10. Those are the 3 possible names. How many symbols are used in a binary system? How about in a denary system? In a binary system, we use 2 symbols. In a denary system, we use 10 symbols. What do you call the binary symbols? How about the denary symbols? Binary uses bits. Denary uses the word digits. So when we're talking about binary and the symbols that we use, the 1 or the 0, we call them bits. When we're talking about denary, all those little symbols, there's 10 of them, from 0 to the 9, we call those digits. All right? Hopefully at this point, you can now explain the difference between a binary system and a denary system, and you can begin to imagine how symbols are represented using either 10 symbols or using 2 symbols.